Alright, so in this problem, I have x minus 4 to the power 4 is equal to x to the power 4. So to start, I'm going to rewrite this as x minus 4 squared to the power of 2 is equal to x squared to the power of 2. And now, I'm going to subtract both sides by x squared to the power of 2. So then these two cancel out. And now I have x minus 4 squared to the power of 2 minus x squared to the power of 2 is equal to 0. Now, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, this is equal to x minus 4 squared plus x squared times x minus 4 squared minus x squared is equal to 0. Now, if I expand this, I get x squared minus 8x plus 16 plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. So this gives me 2x squared minus 8x plus 16 times, these two cancel out, negative 8x plus 16 is equal to 0. So now we have two equations. We have 2x squared minus 8x plus 16 is equal to 0, and we have negative 8x plus 16 is equal to 0. So for negative 8x plus 16 equals 0, I'm going to add 8x on both sides. These two cancel out, so I get 8x equals 16, and now if I divide both sides by 8, I get x is equal to 2. Now for 2x squared minus 8x plus 16, I can factor out 2, so I get x squared minus 4x plus 8 is equal to 0. And now this is the same thing as negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 4, and c is 8. So I get x equals negative of negative 4 plus or minus the square root of b squared, so negative 4 squared minus 4 times a, which is 1, times c, which is 8, all over 2a, so 2 times 1. Now this is equal to 4 plus or minus the square root of negative 4 squared, which is 16, minus 32 over 2, which is equal to 4 plus or minus the square root of negative 16 over 2, which is equal to 4 plus or minus 4i over 2, which is equal to 2 plus or minus 2i. Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So I obviously want to find the value of x here. So for my solution, I'm going to first start by writing 2 to the power of x is equal to 3 to the power of x. And I'm going to take the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log base a of a, this is simply equal to 1. So as you see here, we have log base 2 of 2. And actually before I cancel these two out, if I have something in the form log base a of to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x as my exponent, so I can move this to the front. So now I have x times log base 2 of 2 is equal to, I'm going to do the same thing over here, log base 2 of 3 to the power of x. I can move x to the front here. So now I have this is equal to x times log base 2 of 3. Now remember, if I have something in the form log base a of a, this is equal to 1. So log base 2 of 2, these two cancel out, so I get simply left with x times 1 is equal to x times log base 2 of 3. And x times 1 is simply x, so I get x is equal to x times log base 2 of 3. Now, I'm going to subtract both sides by x log base 2 of 3. So these two cancel out. I get x minus x times log base 2 of 3 is equal to 0. Now if I factor out x, I get x times 1 minus log base 2 of 3 is equal to 0. And if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and I'm left with x is equal to 0. Alright, so in this problem, I have a to the power of 3 plus a squared equals 36. So to actually find all solutions to this problem, I need to first start by finding one solution. So to do that, I'm just going to plug in some numbers and see if they work. So let's try 1. If we plug in 1, we get 2 is equal to 36, which is wrong. If we plug in 2, we get 8 plus 4, which is 12 equals 36, which is wrong. If we plug in 3, we get 3 to the power of 3, which is 27. 27 plus 3 squared is 9. 36 equals 36. So a equals 3. This is one solution of a. And now that we found one solution of a, we can use this later. So we can use this by making a to the power of 3 plus a squared equal 3 to the power of 3 plus 3 squared, because we know that a equals 3. So I'm just plugging in 3 and making them equal to each other. So now I'm going to subtract 3 to the power of 3 plus 3 squared on both sides. So these two cancel out. I get a to the power of 3 plus a squared minus 3 to the power of 3 plus 3 squared minus 3 squared, is equal to 0. Now I can rewrite this to be in the form a minus 3 times a squared plus 3 squared plus three a plus 3 is equal to 0. And this simplifies to a minus 3 times a squared plus 12 plus 49, plus 4a is equal to 0. So now this gives me two equations. I have a minus 3 is equal to 0, and I have a squared plus 4a plus 12 is equal to 0. So for a minus 3 equals 0, a obviously equals 3, so this is one solution of a. And for a squared plus 4a plus 12 equals 0, you have to use the quadratic formula to solve this, and I'm not going to waste your time by doing that. But if you do end up using it, you get that there is no solution because you get the square root of a negative number. So now that we know that a equals 3, remember how this is actually going to be our only solution because this doesn't work. So a equals 3 is our only solution.